Okay, we're gonna continue. Now we're going to preview the table of vacant parcels. Since we don't have any vacancy attribute in the parcel shapefile, we will look for it elsewhere. And in the project pane, under the City of Los Angeles folder, we're gonna go to right click on vacant parcel debase file and then add to current map. So right click on it and add to current map. So now in symbology, go back here and our vacant parcel is added here. So this is a standalone table, has information about puzzles, but no polygons or any other association with spatial features. Standalone tables are added to the table. The contents pane and in a spatial group labeled standalone tables. We open the table by right clicking the contents pane and click open, and each of the 29, it's a lot of record, 29,461 records represent a vacant parcel within the city of Los Angeles. And we will read the column headings. So the OID, object identifier, is sequential number created and managed by ArcGIS automatically. So, and the accessor identification number is a user managed identifier. So, here a accessor identification number AIN. So, right here is the AIN. I'm gonna move this a little bit. It's a user managed identifier. So, the use code field identifies the puzzle use. The city code field is identifies the city in which the puzzle is located. And now we're going to close this attribute table. Close it right here. Close it. Now we're going to preview cities. There are 4 rows of the data requirement table list cities as needed spatial data. We have this data. We use here already. We made a definition query on Los Angeles in the contents pane. We will turn off the puzzle. So we don't want the puzzle and we want our Los Angeles. Maybe we just zoom to our city. Oh no. So in the here we're going to Esri geodata file ESRI, and under boundary we will click under boundary we will have a city polygon, which is right here. I don't think I added there. So city polygon we will just zoom to layer. City boundary. Let's zoom to layer. If not, let's do one more thing. So I'm gonna open attribute table and see what is there. And we right click this contents pane and zoom to layer, and we will see the whole United States, and we turn off this, and we will add city point to the let's see, wow, that's the name. Yeah, we have a lot of cities. Kula, Hawaii. Oh my god. So it's a lot of record. So all the cities that we have. Alright, so now city point. I'm gonna add city point here. And it's also here under the geodatabase. Esri geodatabase add city. Now from the project pane, actual catalog pane, it's folder. In our folder and source data and Esri geodatabase and boundary. And we zoom to the city point layer. Just click zoom to layer. And the main difference between the two feature classes in the city point represents cities as points rather than polygons, hence the name city point and city polygon. There was no difference in spatial extent because city point includes a feature for Attu Station in Alaska, a place which is so far west that is actually in the eastern hemisphere. And we will zoom in to the data see individual features. Why would the same features such as these cities represent with two different types of shapes? We can be point, we can be column, polygon, because each shape is appropriate for a map of different scale. For a national map, we will show cities as points. For a local map, we might show them as polygons. For the requirement, which is to make sure that potential park sites lie inside the city limits, we need features that have boundaries and hence polygons rather than points. So now we're going to turn off points layer. And we will have to preview the Los Angeles River, so it will be in hydro for sure. So we previewed the Los Angeles River in row 5 of the data requirements table. We have rivers as needed spatial data, and we added the river feature. So right here, it's Los Angeles River, and we did definition query on it. And now we're gonna zoom to layer. So we're gonna zoom to layer. There, then we can see our river. So I'm gonna resize this a little bit and move this to the left. And we open the attribute table and scroll to the bottom of the table. So in fact, Los Angeles River is the only river in the feature class, but it is composed of 265 separate features. Find the FID feature ID of the first, second. The first record is 0. Why so many? As noted in here, so the answer has to do with the attributes. So preview the table to see the attributes and then scroll up. I'm gonna draw up a little bit so we can see everything at once. And notice the different values in the capacity, discharge, and and then protection fields. Many of the roads at the top even have empty attribute values. So for the purpose, it doesn't really matter. This attributes mean the point is the river has represented as a single feature, and it would also have just one row in the attribute table. That would mean that only a single value could be stored for each attribute. Fine for the river name, which doesn't change, but a problem for anything we might want to measure or describe at different locations along the river. So, flow, depth, water, chemistry, navigability, or anything else. The creators of this data wanted to gather facts about the river at different places. To do that, they had to define the river as a spatially connected series of individual features. So we don't have that need. All you want is the spatial data. If you end up using this feature class in the analysis rather than river feature class in Esri geodatabase, we would probably combine the 265 features into one. And now we will turn off the Los Angeles river layer, and we will review parks. So parkland, and I have to find parks. So parks is right here. I don't think I added there yet. So now we have a parks. It's right here. And in row 6 of the data requirement table, we need spatial data representing parks. We already know we have a park data. We symbolize and label the parkland feature. There was a shapefile named Parks in the City of Los Angeles folder. We add this here, and we will zoom to the layer and open the attribute table. So the table preview shows that there are 337 records, features, and just a few attributes. So every shapefile feature class has an feature ID and a shape attributes that are created and managed by the software. So the feature ID, feature identification attribute, stores a unique number for each feature. So the shape attribute stores the geometry type behind the scenes. It also links each feature to coordinates that define its spatial location. So measurement attributes such as length and area can be calculated for shapefiles, but if the values change because of a shape added or For example, the software doesn't update them automatically. So a geodatabase feature class has up to 4 software managed attributes. Like a shapefile, it has a feature identifier called objects ID instead of feature ID as a shape attribute. The shape length attribute stores the length of line and polygon features. This attribute doesn't exist for point features. The shapefile area attribute stores the internal area of polygon features. It doesn't exist for point or line features. Shape length and shape area are automatically kept up to date by the software. And now in this project pane under the park data folder, we will add a new park shapefile here. New parks, which is right here. I'm gonna draw on top. So I cannot see, turn this off, and I don't see anything, then zoom to layer. Okay, right here. Okay, so now we open attribute table for sure. So we will have to see the data. So there are two right there. So this shapefile has just two features. One is Los Angeles State Historic Park, and the other is Rio de Los Angeles State Recreation Area. Note that the absence of length and area attributes, we can create them if we want. For example, the park shapefile has them, but they don't exist by default because this is a shapefile format. We will view the metadata for a new park shapefile and right click in the project pane and read the summary. So the data represents two newly developed parks. So when we choose a park feature class for the analysis, we will have to make sure that it incorporates these two parks. So we will turn off the new park shapefile layer and close its attribute table. So we are aware of a third park, Vista Hermosa Park, that has been completed but is not a new park shapefile located just north of downtown. It is one more park to keep track of it. So we will click the locate tool. So locate tool, which is right here. Oh, we have to wait a little bit. So in the inquiry group and a search for Vista Hermosa Park in the locate pane. So I'm not familiar with Los Angeles, especially those detail stuff, but it doesn't matter. So Vista Hermosa Park, Los Angeles, yep. And the park location will be marked the map as an A. So which is right there. And we will zoom in close to look at the park and bookmark as let me zoom in a little bit more. Close everything here so we can see better for the map. Alright, I don't need this. Oh, oopsies, I do. Locate. Alright, so. And then bookmark. New bookmark. So that I will type is Vista Hermosa Park. And then click OK. So we will zoom for a closer look for the park and the bookmark. We already did, and we will preview census units. So now, last time we did census layer as already, and now we're gonna do is we decided to use census units as a proxy for neighborhoods. So in the project pane under the census folder, right here, census folder. And tracks shapefile, we will add that to the map and zoom to layers. So tracks, add this on top, and I already have it here, but I think this might be different thing we gonna use. And the data covers Los Angeles County. The tracts to the north are much bigger than the ones to the south. That is because census tracts are designed to have a very consistent population range, and the northern part of the county with mountains and deserts is less densely populated. I'm zooming somewhere in the southern parts of the city. Add a blocks shapefile to the map. So blocks group shapefile to the map. Previously, we already added. So we add block centroids shapefile to the map. If necessary, we will zoom further to see individual points. So which is right here. So tracts are subdivision into block groups, and block groups are subdivided into blocks. A block centroid is a block represented spatially as a point rather than a polygon. So here the key point is a block centroid is a block presented spatially as a point rather than a polygon. That is not so strange. We have seen the same thing within cities. We can learn more about census units in the sidebar Fundamentals of US Census Geography later in the lesson. So either block groups or tracts will satisfy the spatial data requirement for a neighborhood because of their point geometry block centroid wants. And thus far, we have confirmed that we have the spatial and attribute data listed in row 1 to 7 of the data requirements table. In 3 cases, river, parks, and census units, we have to choose between feature classes. We will tackle that problem later. We will have more data requirement to consider and more data to preview. We must also reveal the requirements for specificity. We will do this in later. And now we will reframe the problem statement. So some of the city council parks guidelines are specific and measurable. On a vacant land parcel 1/4 acre or large within the Los Angeles city limits, others are vague as close as possible to the Los Angeles River. Is there a maximum allowed distance from the river? If so, what is it? Not in the vicinity of an existing park. How close is the vicinity? In a densely populated neighborhood with lots of children, how densely populated? How many children? In a lower income neighborhood, how is lower income defined? Serving as many people as possible. How big an area does a park serve? We can do the analysis until we eliminate the vagueness. So define proximity to the Los Angeles River unless we set a maximum distance limit. Every vacant parcel in Los Angeles becomes a potential park candidate. That's absurd and could waste a lot of data processing time. We will set 1/2 of a mile as an arbitrary outer limit. This stretches the idea of proximity somewhat, but it is just a cutoff point. Hopefully, we will find some good locations that are closer than that. All right. So now we will have to back our folder. So let me back to my folder. And once I have the folder, and I'm gonna go to here, there, data requirement table. Alright, so here in row 5, that of the requirement table in the define as column, we will say define as a column near the river. We will say less and equal to 0.5 miles. Okay, and define away from other parks. So what minimum distance should a candidate site have to from existing parks? In open space planning, 0.25 miles is often used to define a convenient walking distance. That is typically about a 5 minutes walk. Following that standard, we can say that a site is not in the vicinity of an existing park if the nearest park is at least 0.5 miles away. In row 6 of the data requirements table in the define as column, we will enter right here, we will enter greater and equals to 0.25 miles. And this measure is a simplification because it's based on straight line distance. Okay, now we will talk about the fundamental of U.S. Census Geography. So for U.S. Census Geography, I'm gonna post something out and to help out U.S. Census Geography. Let's see what is common in U.S. Census Geography. there, so that we can learn a little bit. So the U.S. Census Bureau reports data by various geographic units. So the top to down relationship shows here represents containment. The nation contains states, states contains counties, counties contain tracts, tracts contains blocks, groups, and block groups contain blocks. So this relationship, um, many other non-nesting reporting units are not shown here. So, um, the point here is census tracts are relatively small subdivisions of a county. They typically have between 1,000 and 8,000 inhabitants and vary in size. They are designed to be very homogeneous with respect to demographic and economic conditions. A block group is a cluster or blocks within a tract. A block group typically has between 600 and 3,000 inhabitants. A census block, commonly an ordinary city block, is an area bounded by visible features such as streets or railroad tracks, or by invisible boundaries such as city limits. A block centroid is a census block represented as a point rather than a polygon. A centroid is located in the geographic center of the block. It represents and has the attributes of that block. So, the Census Bureau conducts a few censuses every 10 years. The latest one was conducted in 2010. Professional demographers estimate values for the intervening years. And now, and now we define a densely populated neighborhood as we make the rest of the requirements concrete. We will also make sure that we have the appropriate data. So often the attribute table of the tract shapefile layer and scroll across the attributes. So as shown here in the figure, the population density is in the pop densities field as noted in lesson 1. So here this attribute stores population per square miles for the current year. So I have to go back to our tracts data. So tracts, and I open attribute table so that we can see better. So now, and we open the attribute table, and this attribute stores population per square miles for the current year, and here is the census for the year of 2015. So the table has many of the same fields as the tracts shapefile table, but there is no population density attribute. This won't be a problem because population density is just total population divided by area. Because we have a total population, we need only the area of each block group, which is something that ArcGIS Pro can calculate automatically. So either shapefile satisfies your need. Tracts already has population density, and we can derive it from block groups. So we still need a definition of densely populated. To keep it simple, we can call a neighborhood densely populated if its value exceeds that of the city of Los Angeles. The population density of Los Angeles as of the year of 2015 was 8,474.7 people per square miles. Rounding down to an even number, use 8,500 people per square miles as the threshold. So in row A of the data requirement table, in the defined as column, we will enter back here, row 8. Here we will say greater and equal to a 500 per square mile. So the threshold value to find the population density of Los Angeles, as well as other threshold values for the analysis, we used online U.S. Census Bureau data, especially Quick Facts page. So, they do have a Quick Facts page. Census, U.S. Census Quick Facts page. Okay, we can just go to Quick Fact. Yeah, there. So that's the quick fact page, and you can find more information there. And then we will define lots of children. Again, we will look for attribute and then set threshold. So now we will back here again. We will open the attribute table for block groups. So population, I don't need locate anymore. So those are population of this is a population age 18 or older for the year 2015. So I will have population 21 up. Close this, I cannot see right here. Alright, population 21 up and and you can see 18 up. So this is the population age 18 or older for the year of 2015. We will define as a child as a person under 18 with a reasonable. We will subtract values in this field, population 18 up, and from those total population and CY to get the number of children. So because the neighborhood vary in size and population, we can make more valid comparisons if we base the threshold on a ratio rather than an absolute number. So in Los Angeles, 22.2% of the population is under 18. We will therefore define a neighborhood as having lots of children. If it meets or exceeds its value. So we can derive the percentage of children from the data using simple arithmetic. So in row 9 of the data requirement table, so we will define as the column. So now I'm gonna go is here enter greater than lots of children greater and equal to 22%. In the attribute data column, we will replace the entry age. So entry age here with age under 18. Age under 18. And we will define lower income. How would you define it? So now we will look at the income attribute. So we will open the attribute table of block groups. So back in here, block groups, and open attribute table. And we will scroll all the way to the right. I don't have to because my screen is big enough. So the last two attributes might be income measures. So to find out, we will look at the metadata, not the item descriptions we looked at before, but the full data documentation. So which is right here, and we will click the project tab and on the far end of the ribbon and click options. So which is right here. Oh no, I don't want to export. So far, click project tab right here, options, and we will click metadata in the left column, metadata right here, and item description. We will say, yeah, it is item description. We will change metadata to North American profile for 2000 ISO 19115. Okay, 2013. Oh my god. Can you explain 10? Yeah, I remember that number, but do I have to remember? Yeah, I do. So I might have to look it up. So for the ISO 19115, let's look it up right now. So okay, what is ISO 19115? Okay, alright, so Standard International Organization. So this is the ISO 19115. This one you have to remember. I will take a note for sure. So, okay, because I don't like to remember, but it's good to remember most of the time. So metadata. Okay, this is a standard of the international organization for standardization. ISO. Alright. Standardization. And I'm gonna go back to her. Click OK. And then we will return to the project using this arrow. So it didn't have anything showing up. Now we were changing the metadata style, gives you the access to the full set of metadata from the dataset. And we will see the sidebar metadata layer later in here. But if necessary, we will open the project pane and browse to Park site and source data and sensors. So go back to view and bring our catalog pane. Everything's still here. And we will click block group shapefile and click view metadata. So is it Centroid? No, group. Okay, right here. So view metadata. Okay. And I'm gonna close this two out, so I might not need the preview. I want the detail. The metadata is divided into three sections that can be expanded or collapsed. They are expanded by default. So right now it's all expanded, okay? And we will click topics and keywords to collapse it. Right click block group shapefile and then click metadata. Collapse the next several headings in citation contracts, and so on until we come to the fields heading. So this heading contains the metadata that we are interested in. Scroll through the field data. So everything is here, field data. I don't see the field data. Topics and keywords right here. Citation contracts, contacts. All right. Fields data. And scroll down until we see the field. Okay, right here. And the first one, oh my god, I have to scroll on this side. If not, the other part is not working. So, field average. The youth and everything know that is described as the 2005. So, okay, right here. So 2005 total population, household information. Yep. And we want to find its averaging. It's all here. Population. For the population, know that the MED, median house income. I think it's at the bottom a little bit. MED, median household. Right here. Household income. There. So median house income and average CVI, average house income right here. Okay, we will finish it up. So the metadata is a description of what is known about a data set. So it's basically just data about data. It serves two important purposes. So the first one is it vouchsafes the integrity of data by explaining things such as how, when, and whom the data was created. And second, it takes the data searchable. Metadata includes tags that identify essential properties of the data. For example, reverse Los Angeles in 2010 and other descriptions that makes it possible to find specific datasets among large inventories of spatial data. And metadata may be kept according to one of various official standards and data created by government agencies, commercial data vendors, and many large enterprises typically conforms to one of these standards. And data created by small organizations or by individuals commonly does not. In ArcGIS, metadata can be displayed in a style that is suited for a particular standard, and the default style is the item description, which display a thumbnail image of the data and a small amount of important information. And this style is suited to metadata that is not kept to an official standard. It can also be used to provide a fielded summary view of the metadata that is kept to an official standard. Anyone who creates and shares data should at least maintain metadata at the item description level to see the full metadata for a dataset that is kept to an official standard. We must change the metadata style in ArcGIS Pro under Project Options. All the styles apart from item description are similar and all afford access to the full set of metadata, no matter what standard they conform to, though they may present the information slightly different. And now both are good possibilities. Median income is statistical midpoint. It marks the value that half of the household are above and half are below. So we will have to remember that. So the median income, that it's very interesting that you can see a statistical midpoint. So it marks the value that half the household are above and half are below. And we will adopt this measure because it is less sensitive to extremely values. So a millionaire in a low-income neighborhood might significantly changes the average income, but not the median income. So according to the U.S. Census Bureau, so the median household income for the city of Los Angeles for the year of 2010 to 2014 is 49,682. So running off, we will call a neighborhood a lower income if the median household income is 50,000 or less. So now, in row 10 of the data requirement table, in the define as column, and we will say enter, go back here, lower income, so it will be less and greater than US dollars, 5123. Oh, no, not percent sign, it should be US dollar sign. And now we will define serving the most people. Okay, that will be our last criteria. We're almost done. Okay, so finally, we want to know which potential site serves the most people. Anyone can come to a park. So for this criterion, we want to count all the people nearby, regardless of their demographic profile. The attribute we need for this element is total population, which we have in both the tracts and blocks groups feature classes. We will treat the skylines as preference. If half a dozen sites meet the other requirement, we prefer those serving more people overall to those serving fewer. Eventually, this preference may have to be subjectively weighted against others. For example, which is better, a park closer to the river that serves fewer people or a park further from the river that serves more people? How much closer? How many more people? So to define the size of the area served by a park, we would apply the standard of easy walking distance discussed earlier and say that a park serves anyone who lives within a quarter mile of it. Serving the most people, therefore, means having the largest population within a 0.25-mile radius. And then we will open Block Centuries table and browse across the attributes. So now we have to add it back first. So now I'm gonna close our catalog. View and then arc there, Centroid, and right click on it and attribute table. Yeah, alright. So now we have the attribute table open, and this table also has a total population. Attribute population 2010, we cannot use blocks and centroids as our spatial data for neighborhoods. We need polygons rather than points, but we can conveniently use them to some population. Give a distance of a quarter mile around the park. ArcGIS Pro can count the blocks and centroids or points that fall within this distance and add their population values. So in row 11 of the data requirement table, so define as column, we will back here, serving most people. So we will say will be okay, there, less than this and 0.25, and gonna save it. And the data requirements table should look like this now. Perfect. And we can now state the problem in measurable terms that allow us to solve it with a GIS tool. Someone might take issue with the interpretation of the city council's park guidelines, but that's fine. We will always be happy to improve the methodology. For now, we can state the project analysis requirements as follows. We want to locate a site for a new park or on a land parcel that is vacant, a quarter acre or more in size, with the LA city limits with 0.5 miles of the Los Angeles River, and preferring close sites more than 0.25 miles from the nearest park in a census unit in which population density is 850 or more people per square miles, where at least 22% of the population is under 18 years old, and where median household income is 50,000% or less, and considering that all other considerations are satisfied. The total population within a 0.25-mile radius is maximized. So we have formalized the data requirements in a table and confirmed that the essential data is available. In some cases, multiple datasets contain suitable features and attributes. In the next section, we will compare these datasets, choose which ones to use the analysis. And now we will close everything and save everything, and we will move on to how to choose the data. So, alright, we will see you soon.